Emilio, welcome back. Thank you very, very much for accepting my second invitation to talk to you. By the way, this is episode 3 of It Depends, where we're going to focus on mathematics and entrepreneurship. So for a little bit of context, I met Emilio through a common friend, and we talked briefly about entrepreneurship in a first interview, and it was so insightful. You definitely are someone that thinks deep about stuff, and I deeply appreciate it. I think the world needs more of that. So why don't we start by introducing yourself a little bit?
Yeah, sure. So thank you for having me, Alex. And I'm a current master's in applied mathematics student at Imperial College. I've been doing that part-time while I've been working on my startup, NEA Studios. So we provide kind of digital solutions for rural areas of Europe. And now also I'm part of a new project that I started here at Imperial, where we secured £50,000 to build a new community garden in that space.
Huge congratulations. Raising funds at the moment is no easy. There is a lot of uncertainty around who knows for how long, maybe forever. We'll never know. So for me, I've always seen math people as the cool guys, as very aspirational, just because I find mathematics as a way to give my life some structured, or maybe my mind some peace. So my first question is, have you ever felt like math could solve all of your problems?
I think maybe towards the beginning of my degree, I did think that physics and maths was kind of this framework to understand everything. Now, after kind of 5 years of going through that journey, I see maths more as a tool, kind of like a hammer that can solve problems, and not so much kind of as a gospel with answers in it. What I have felt like while learning with like the mathematical model of how to think about problems and break it down to chunks and definitions that you understand and then use those to build up into some kind of theory is a really good way of approaching problems outside of maths. So I think as a tool or as a method, it can solve problems, but it's limited in terms of what you can achieve with it.
Mm. Do you think studying math kind of changes your mindset, like as you were saying, the way you see life, not only from a problem solving, well, yeah, from a problem solving perspective, apply to your love life, your friendship?
Yeah, so I think it does change mindsets. I think there's uh, like a structure to thoughts that
Mm.
is what mathematicians we get trained to do, or like what really good mathematicians can really do is kind of like get words and assumptions and play with that and evolve that into theory. And I think we, as mathematicians, we tend to take that into other places.
Mhm.
And that could also mean, like, as you said, your love life. So I think, for example, I really like trying to solve disputes or like conversations, not just in my love life with my friends, but use it kind of in like a rational approach and try to understand what we know about the problem, about each other, about what we have, and what can we build from that together and see what we get there.
That's awesome. You see, that's why I love my math friends. So what do you think is the difference between uncertainty and error in mathematical terms?
Hmm. So I'd say that error, I mean, purely like definition wise, error is just the difference between what you're predicting and the true value of what you're trying to predict. So how bad your prediction was, for example.
Mhm.
And then uncertainty is more on what you're predicting and how confident you are on your prediction being accurate to the true value. So yes, I think one of them, so I think error is more like after prediction, and
Mhm.
uncertainty is things you pick up while you try to make the prediction.
Okay. So as you were saying, error is how wrong you were. And usually, well, at least when I was doing the research for this interview, the statistics, you have proximity and then just basically getting a range of values that will take you closer to the real value. But my problem with that assumption is the word range, because it equals variance, and then it equals inaccuracy. So basically that question is very interesting to me. So I wonder, what do you think is scientist range discussion, and whether you think this takes us further from the truth, or it helps us to reach the truth? Like when you're learning to ride your bike and then you have the training wheels, they say that the cushion is like the training wheels. Do you think that's helpful or not quite?
I'm not a statistician, so I might be falling like outside my depth. But there is kind of like a lot of usefulness in being able to look at things that are not fully accurate. So like at least the way I see it in the real world, nothing you can really measure is like fully accurate, and like it's not deterministic. Well, at least in my view, the world's not deterministic. There's a kind of like this noise around everything we do in our eyes, in our measurements and instruments. And if we couldn't take measurements that we take because they're noisy, then we can't really do anything. We can't measure the world. We can't apply things. So to a level to do things pragmatically, you need to have kind of a confidence cushion that allows you to do things and move forward with assumptions and carry errors and uncertainty forward. And in mathematics, especially, statisticians have a really good kind of framework that has been developed through years and years to be able to kind of discover truths from things that are not certain. So kind of things with variance, as you said, and still be able to say that within a confidence range, that answer is true. And that really helps with science, like especially in biology, where a lot of it is kind of like measurements are quite noisy. Then being able to prove your hypothesis to a certain level of confidence means that science can progress forward, right? That makes sense?
Yeah, it makes total sense. I'm just a bit shocked because I always thought that exact science was about exact results. So the fact that you acknowledge the world is noisy and there is a lot of there are margins of errors that don't necessarily mean that it's not worth measuring with being exact. It's like a traveling idea, because I was used to thinking about mathematicians and math and physics as it is either 3.235 or you die, or is wrong and the rocket explodes. So it definitely changes the way I see the world, because I'd never considered the margin of errors that is just embedded. So in economics, we call it systemic risk. It's a risk that you cannot avoid. I guess that's also applicable in math. But then to get closer to the truth, do you try to get as exact as possible, or you try to reduce the noise as much as possible?
I think it's both. I actually kind of, I think in A-level physics, I really get confused with accuracy and precision. Like they're two different terms that mean different things. One relates to uncertainty and one relates to error, in fact. In fear of getting it wrong, I'm not going to say any more on that. But I think generally going like to the analogy that you had earlier about the rocket, I think a lot of what science is about being able to say that within 3.25 plus or minus 0.001, the rocket won't explode. And then that we can show, that we can be safe. And then that means that even if our measurements are not fully accurate, the machine or the concept of what we're trying to do will still succeed, and we can still carry forward that error. And it just like usually an experimentalist will try to reduce the sources of error as much as possible. So in your lab, you try to get your best equipment. You're trying to have the best practice, especially like when you're measuring things, and the way you're measuring things can reduce error. And then more like on a theoretical level, when error is a bit made up, you actually care more about how much. I mean, it's interesting from a theory perspective, at least from what I study in dynamic systems, is that it's really interesting to see what happens when you have unbounded error or your noise is really big, and what results you can actually kind of retrieve from a worst case scenario of measurements. And it's a combination of both that I think end up with really good theories in practice.
I love that. So let's take two takeaways from what you said. The first one is, do you agree that the tool against uncertainty here is to get to boil down to the range of confidence?
Yeah, I think Gary, the a practice is doing that, is being able to say that even if our numbers are not going to, we don't know what the numbers are going to be because of limitations, the system's still going to hold.
That's awesome. And then when you talked about hypothesis and theoretical mathematics, I guess, you mentioned that there is a lot of noise and you kind of have to deal with that noise. And that reminds me of quantum a little bit. I don't know why, but I developed an obsession with quantum physics, especially when I realized that I thought that was like a theoretical thing, that it doesn't exist. But apparently it does exist. It's happening right now. It blew my mind. So by definition, quantum logic models a world where you cannot know everything at once. And when you try to measure it, it kind of destroys the wave function, collapses the system. What do you think quantum teaches us about the exercise of forecasting and prediction and reducing the noise?
Quantum mechanics was a big realization, at least from like the physics perspective, that
For me,
are so yeah,
for me as well.
for everyone, yeah, because classical mechanics was kind of what physicists used before, and we still use it. But with classical mechanics, you have a deterministic system, so things go from point one to point two, and then in quantum mechanics, you start to kind of introduce this kind of Heisenberg uncertainty principle, which gives you a relationship between the error or the uncertainty of position and speed. So if you know the position of something really well, suddenly like the uncertainty on the speed skyrockets. And if you know the speed of something really well, you don't really know where it is in space. And that means that your system evolves probabilistically. So one point turns into kind of a cloud of points that it could evolve to with different probabilities. And then that cloud evolves into another cloud of different points with different probabilities. And it just brings a new way of interpreting and modeling systems. But mathematicians kind of, with quickly, I mean, this theory is really well developed now. We have kind of the tools to be able to still make predictions with that kind of noisy systems or noise-induced systems. And actually, we kind of get a lot of cool concepts emerging from there, kind of like the attractors are still real, so you can still kind of be attracted to something even though you're noisy, and kind of the whole ergodic theory and stuff like that, or quantum tunneling, for example, that's unique to noisy or quantum systems. So I think it kind of opens a new whole, like a kind of worms in a good way of like new possibilities and things that can happen. And it really just comes from interpreting things in a different way.
So basically, even though let's say quantum is happening right now in photosynthesis and stuff, we cannot observe it. The whole fear or inability to be aware is what really freaks me out. But then, even though we have this inaccessibility to it, we can still learn that there are new perspective that we can use to see a situation. But for example, in finance, a lot of people are talking about a new way of that the world is organizing. So it is the perfect time for you, if you're working in finance and economics, to start guessing where the new world power is going to be and that what they're going to imply for the rest of us. But there are just so many scenarios and hypotheses that you can make without going insane. And then if you apply that to quantum, like the possibilities are endless. And then you were talking about the new clouds that are formed and the new ways that these paths can take. That's all well and good, but how much do you think you can forecast? And maybe this could be a good segue to my next question to considering entrepreneurship. How much you can forecast with accuracy and basically without going confused and insane?
Yeah, no, I get what you mean. I think the real like trick I think I realized doing noisy and like what's called random dynamical systems, which is basically kind of pre quantum mechanics kind of theory. And or I mean, a lot of what we do ends up being applied in quantum mechanics and quantum physics. And the thing is that even though you have a system that is noisy and random, and we kind of as humans cannot really visualize random, we're deterministic by nature. So if you have a pen, you can predict if I throw the pen how it's going to go in your head. But it's difficult for us to then imagine kind of that pen and then suddenly going into a cloud of pens in different places that could exist, and they have different color depending on the probability of them being there or something like that. And even with that like non-intuitive way of thinking, it's how bigger things outside quantum behave. So in your case, this is a macroeconomics levels of like who takes power or where the new regime falls, and being able to still identify patterns within systems that have branching paths, and being able to still make almost sure estimations or forecasts on systems that are noisy is a tool that is very useful for specifically these reasons. So I think there's a lot of mechanisms that can be used in quantum mechanics or in random dynamical systems that are now kind of being taken to the bigger kind of economic finance, sociology kind of level of analysis that we need to take. And it just helps deal with uncertainty much better in terms of, like it's the tool to deal with uncertain systems.
That's incredible. I love it. And when it comes to entrepreneurship, you know that the quicker you launch your product, the better, because you can start training your model with your own data. It's kind of very similar to what we were discussing. So it might happen this way, but it might not happen this way. You just have to launch. Do you think then that quantum uncertainty kind of mirrors the entrepreneurial journey?
I really liked this question when I was reading it, because I thought it was such a fresh perspective on this entrepreneurial world. Because kind of like in the way I was imagining it is kind of like the Schrodinger's cat.
And I
like
hate that it's a cat because I love cats. How dare
yeah. Well, it's still alive. So it is kind of like a black box when you start a startup, and like you have all of these assumptions that you make, and when you're starting the startup, you are in the superposition of being a company and being a failing company at the same time. And it's until you get like your first paid customer, until you launch, and then the market decides, yes, you're a company, or no, you're not a company. And I think it's true in there, like in that perspective. But then like with that analogy, the like what I think is a smarter way of doing entrepreneurship is to go for leaner approaches. So if your assumptions are exposing you to risk or like your uncertainty, which is kind of the same, then you have to cut down on assumptions, or at least try and test and prove those assumptions. And I think that's what the lean business model tries to do, and trying to come with something, one assumption, prove it, then build with another assumption, prove it, and then build that. And that way you minimize your exposure. And I think that's kind of like the same way. It's you're still in this like you're going to be right or wrong, right, on the leap. But perhaps by constantly testing in smaller steps, you're actually less exposed to a big leap.
I know, and that's very insightful. Thank you. It definitely, I'm going to be thinking about it for a long time. Because yeah, as you said, you have to be as lean as possible, but there is a temptation. At least, I worked for a startup for a little bit, and there was a lot of urge and need, at least from my side, to look at competitors and see what they are doing, to gain some clarity. But then that is ultimately a mistake, because what works for them almost never works for your own company. And in finance, we have a term called risk premium, which is like the reward you get for taking extra units of risk, which means that in order to get the more risk premium, the more prepared you have to be, and the more you have to dig and analyze the market. It's basically, in finance, we basically want to be as aware as possible of what's going on in order to make a decision. And then if we lose, then we know, at least we knew our cards and what was the game. But in entrepreneurship is the opposite. You have to go to war blind. Do you think there is a source of this kind of risk premium in entrepreneurship?
Yeah, I mean, I do agree that risk, I think risk is inherent to entrepreneurship. And it's mostly because if you do know 100% of what's going on and you're fully aware, then you're probably not innovating enough to make your company a startup, right? So I think in that case, we are exposed to a lot of risk, and I think investors in the startup world are aware of that, and so are founders, right? So when you're an investor and you are writing a check to a startup, there's a lot of certainty still, because like a lot of like deep tech startups have like this research and years of backing behind it, and then they're just kind of like in the business model launching. But a lot of them are kind of like wild guesses, and a lot of VCs will write a lot of checks with the idea that a lot of these are wild guesses and a lot of them will fail. But then you will have one unicorn in your portfolio, and then that will pay for 20 failures and plus profits on top of it. And I think that's what the premium is in startups. Like when you go out fundraising for that money, people are going to want to take a chunk of your business, especially the earlier in, like you can go, sometimes you can go looking for angels that will ask for like 50% of your business because it's risky, it's their money. And if the confidence is not there that your team or the idea will succeed, people are going to want to make sure that they're as protected as possible. And that means higher stakes.
And then also when you're in this angel state, let's say, you're still in your business still in the box, the black box. So it's a failing business and a successful business at the same time. So thinking it that way, 50% might not sound that irrational.
No, I mean, especially considering like the odds, a startup succeeding is like less than 20% nowadays. And like that's, you're better going as an angel to the casino and like playing some games there than actually investing in startups. But people do it because it's a kind of innovation, and like you can make a lot of there, and there's value and impact and the prestige. But it really is a difficult space. So if you are an angel, it is justifiable to ask for 50% of a company if you kind of have to pay £500,000 for it upfront, right? You're enabling that space, right?
Wow, insane risk premiums.
Yeah.
I have to like have a look at the VC world at the moment. It sounds interesting. So if you had to give one mathematical idea to help people feel more at ease with uncertainty, what would it be?
So I believe that uncertainty, like on kind of a general level, generates the biggest potential to create value. So the more exposed you are to uncertainty, the easier it is to kind of leap into a higher level, whatever it is. So it's kind of again a concept of quantum mechanics that I quite like is quantum tunneling. So in a deterministic system, if you have a wall here, your particle is not going to cross that wall. But if you add noise, there is a case where with enough uncertainty, enough noise, your particle can make it to the other side of the wall. And that means they can overcome challenges and push through new barriers. And it really goes down to a personal level on how to deal with uncertainty. And I think the rule that I tend to use for myself, it's not mathematical, I'm sorry, but like the rule that I do use for myself is to be in classroom conditions. So to think that if I'm assuming risk or uncertainty with an action, how much, like, am I gaining any value from that action? If the answer is no, then you don't have to look at it, like ignore that move. If the answer is yes, then you have to think, okay, if I fail, like if I'm not within the cushion, are the consequences of it trivial? So like, do I actually care about the failure? And also, or are the consequences something that you can fix easily? So can I just do something else and repair myself? And if you put yourself in those kind of conditions, it's really easy to assume risk into your life, and then that allows you to grow, I think, and in good ways sometimes.
Oh my God, that's so awesome. I think I'm gonna steal it. Talk to my friends about what was it? Quantum tunneling.
Yeah, quantum tunneling.
Let's say that we want to put this concept into like an equation, very simple. It might be like net present value, which equals the uncertainty, which could be the expenses, let's say, of what you want to do. And then you add the possible benefits that you will get if you were to do this project. So if the possible benefits is greater than the uncertainty, then it's good. And then the other.
Yeah, that would be a good way of looking at it. You have to do like some multiplication with like coefficients and stuff, probably, like depending on how easy it is to like how easy it is to repair a mistake. That depends also. So if it's really easy, then maybe it's like a zero, right?
Yeah.
So then your uncertainty that you're assuming, or the risk that you're assuming, goes to zero, because it doesn't matter, you can fix it anyways. But if it's really difficult, maybe it's like something like 1, and then you're like, okay, now as much uncertainty as I'm assuming, I'm going to have to fix. And then you can do something similar with like another coefficient for triviality. So if it's something really trivial, it's 0. If it's something really important, it's 1. So for every unit of uncertainty, you assume you get a fraction based on triviality and how easy it is to fix. And then it's about value at the end. If the value is 0, you don't have to do it.
Yeah, sure. You are such an entrepreneur. Already thinking about fixing. Fixing was not in my radar. Like the less things I have to fix, the better. So
Yeah.
that's great. You're literally the most entrepreneurial person I know. Thank you so very much for accepting my second invitation.
No worries. Thank you for having me.
I had a great time. See you soon.
Me too. Thank you.